Every giant was once a baby, though you may never have seen them at that stage of their development. NASA's most advanced space telescope is shedding light on the formative years in the history of the universe that was far beyond our reach until now. In June 2022, the James Webb Space Telescope discovered plenty of faraway galaxies when it first took its deep field image. Suddenly, galaxies started to pop out from the darkness of time and space, revealing themselves. The universe, for the first time, started to seem way stranger than we ever thought it to be. Galaxies emerged from what we believe to be the universe's dark ages, raising doubts over the science of our cosmic model. And it wasn't just a couple of galaxies. The Webb telescope found hundreds of them. One of these galaxies was found by an Austin astronomer, Stephen Finkelstein. He named it Maisie's Galaxy, an ode to his daughter because they spotted it on her birthday. Initially, the scientist and his team thought that the galaxy had formed almost immediately after the Big Bang in cosmic timescales. Yes, they estimated it to have been around only 290 million years after the Big Bang. But after analyzing the galaxy with more advanced equipment, they found out that it's about 100 million years older than that. That still doesn't take away its title from being the oldest galaxy ever observed, formed only 390 million years after the Big Bang. However, the record holder of being the oldest galaxy ever observed might not enjoy the first place for too long. Currently, there are about 10 more galaxies that the Sears team is now evaluating, which could be even older than Maisie's Galaxy. We're seeing a rise of massive galaxies faster than we previously thought, said Fabio Pacucci of the Harvard-Smithsonian Center for Astrophysics. The ages of some of these early galaxies are estimated at just tens of millions of years. This could have implications for large structures of dark matter known as halos that, according to our cosmology, sculpted early galaxies. Yes, some problematic and potentially model-busting early universe candidate galaxies still remain, and the first among them may be a class of galaxies identified by a team of scientists at the Swinburne University of Technology in Australia. The team found galaxies with billions of solar masses, comparable in weight to the Milky Way, from just an estimated 750 million years after the Big Bang. These galaxies are 10 to 100 times bigger than galaxies previously seen in this era and are packed into structures 30 times smaller than the Milky Way. What is more intriguing is that the galaxies seemingly are hosting many more stars than we thought would be possible. Indeed, the very fundamentals of our understanding of how massive structures build up over time has challenged the cosmological standard model. Remember what Michio Kaku had said last year after these very early galaxies showed up in Webb images?
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist 500 million years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen. There should not be primordial galaxies that are bigger than the Milky Way galaxy that are only 500 million years old. Something is wrong. We may have to revise our theory of the creation of the universe.
That was from last year. Not only did we discover more distant galaxy after that, recently, Webb detected Milky Way-like galaxies at the edge of the universe that, according to our physics, should not exist. Many early galaxies, like the ones the JWST detected, were rich with glowing gas so bright that the gas itself could outshine stars emerging from within. These new findings reveal just how common such shimmering, infant, gassy galaxies were when the 13.8 billion-year-old universe was around only 2 billion years old. Observations now reveal that almost 90% of the galaxies had so-called extreme emission features, meaning they exhibited all that glowing gas. And while studying these early galaxies, astronomers stumbled upon the most distant example of a galaxy in the universe that looks like our home galaxy, the Milky Way. Yes, you heard that right. When the universe was just 2 billion years old, the newfound spiral galaxy, Sears 2112, appears to have featured a bar of stars and gas cutting across its heart. But wait a minute, how is that even possible? Our galaxy, the Milky Way, is also a spiral galaxy sporting a similar bar. Scientists suspect the Milky Way's bar rotates cylindrically, funneling gas into the galaxy's center and sparking bursts of star formation. Astronomers previously thought this galactic structure marks the end of a galaxy's formative years, so it was expected to be seen only in old galaxies that may have reached full maturity, perhaps those that existed halfway through the evolution of the universe. And with the Hubble Space Telescope's past observations of galaxy morphologies, we thought the early universe hosted very few barred galaxies. However, everything that we know about the early universe is changing. The new findings gathered from data by the Webb telescope conclude it may not be necessarily true that barred spirals must have existed only recently in the universe. The discovery of spiral galaxies Sears 2112 reveals galaxies that resemble our own already existed almost 12 billion years ago, when the universe was just 15% of its current age. Yes, Sears 2112 is observed at a redshift of 3, when the universe was 2100 million years old. Essentially, this means the light from the galaxy took almost 12 billion years to reach the James Webb Space Telescope. This is a surprising find, as galactic bars seen in the galaxy are thought to have manifested about 4 billion years into the birth of the universe. The standard model of cosmology predicts that the early universe's physical conditions must have prevented the formation of such barred galaxies in general. But here we are. Not only that, even theoretical predictions from cosmological simulations really struggle to reproduce such systems at those epochs. So what is going on? We now need to understand which key physical ingredient is missing in our models. If something is missing, said one of the scientists associated with the discovery. Now, if you think this is it, here's the crazy part. Scientists believe that 85% of all matter in the universe is dark matter, a mysterious substance elusive to observations because it doesn't interact with light at all. Dark matter is thought to have radically influenced galaxy evolution and star formation from as early as 380,000 years after the Big Bang. Findings from the new discovery, however, show galaxy evolution, at least in the case of Sears 2112, was dominated by ordinary matter and not dark matter when the universe was about 2 billion years old. Yes, it's a big discovery, and it confirms that the evolution of this galaxy was dominated by baryons, the ordinary matter you and I and everything we see are made of, and not by dark matter, despite its overabundance. Well, that's new. At this point, I don't think anyone is expecting anything other than new from the James Webb Space Telescope. These are exciting times. We are living in an era that will see a great transformation in cosmology. The secrets of the universe are now within our reach. What do you guys have to say?